From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show.
If you work on an Android app, and if you're listening to this podcast, I'm going to presume you do, you will know that when your user reports a problem or a crash, it's the absolute worst feeling. To make matters worse, they might one-star your app, go on Twitter and complain about the app, and if they're feeling particularly merciless, probably go on Reddit or something and post it there. But you know what? They have absolutely every reason to. If you treat your customers basically as an offsite QA team, it's rude to them and it's just bad for business. As developers, we don't want to rely on customers to report errors. Instead, we want to catch this much early on. Ideally, you just have automated tests and these tell you when there's a problem. But as we've talked about on the show multiple times, that's not always as easy as we want it to be, because writing tests can be hard. That's why Sentry, our sponsor for today's show, tells you about errors in your code before your customers have a chance to encounter them. Not only do they tell you about the errors, they also give you helpful details that help you fix these errors. For example, how many users were impacted by this bug, the complete stack trace if it's a crash, the commit ID when this error was released, the engineer who wrote this line of code that was busted, that and a whole lot more. If your code is broken, let's fix it together. That's Sentry's tagline. Love it. You can check them out at sentry.io/for/Android. Sentry is a pretty common word. It's actually a pretty cool name for the service if you know the English meaning of the word. But I want to make sure you get that domain name right. It's sentry.io. Once again, sentry.io/for, as in FOR/Android. Check them out today and fix your errors before your users encounter them. Thanks for sponsoring today's show, Sentry. How many of you saw the Flutter Live event held in London on the 4th of December 2018? Google announced Flutter 1.0. We've talked about how awesome it could be building apps with Flutter, but at the same event, a startup in Estonia partnered with Google to announce a brand new CI and delivery service tool called CodeMagic. This startup is Nevercode, and Nevercode built CodeMagic. Today, I'd like to thank them for sponsoring this show. CodeMagic is the first CI/CD tool created exclusively for building Flutter applications. The idea for them was, without any deep technical knowledge, app developers like us should be able to easily configure the whole flow for the Flutter platform to the users of our app on the Play Store or App Store. Because remember, with Flutter apps, you can easily build both Android and iOS applications. It's a cloud-based CI/CD tool for building, testing, and publishing Flutter apps. Users log in via GitHub and select the repository containing their Flutter application, after which they can immediately start a build with pre-configured defaults. Even the folks at Google working on Flutter have had great things to say about this. For example, Tim, the group PM for Flutter, said this: Nevercode has a really good understanding of the workflow that Flutter developers want. Their CodeMagic product takes all the pain out of the build process. That's pretty cool. So if you're a Flutter dev, build, test, and publish your Flutter apps in record time with CodeMagic. Go ahead and check them out at codemagic.io. But here's the kicker. For the time being, the tool is available to everyone at no cost because they just announced it. It's totally free. But in the future, it probably will include paid options in addition to the free plan. So you should check them out while they're still hot from the presses. Thanks for sponsoring today's show, Nevercode.
Today we're going to talk about returns and jumps with labels in Kotlin. If you've been developing Kotlin for a while, you may have seen some odd-looking code that has an @ symbol in it. Usually further down in the code, you'll see something like break at foo or return at foo or something like that. Now, when you first see these things, they can be rather confusing. My goal is to explain what they are, when and how to use them, so that you have a better understanding of their usage in your applications and how you can implement them. So let's start from the top. There are 3 different keywords that are known as jump expressions in Kotlin. Hold up. You're probably wondering, what the heck is a jump expression? If you don't study new languages that often, it's probably something that's difficult to wrap your head around by just hearing the words jump expression. And no, we're not talking about this song either. Nope, not that one. Okay, so what are they? Jump expressions are logical pieces of code that allow you to program to jump to other pieces of code. Anyone remember the old go-to statements from a long time ago? Hopefully not. And thankfully, we're not talking about go-to statements. However, we are talking about a similar thought process. When your code encounters a jump expression, the type of jump expression it encounters decides what it will do. In Kotlin, there are 3 structural jump expressions: return, break, and continue. We're all familiar with what return does. For example, if you have a function that calculates the number of points a customer has, you could do something like this. Fun, calculate points, and this would be a function. It would take in a parameter of a customer object, and perhaps this customer object has a couple of flags on it, such as, is the customer platinum? The function would return an integer value representing how many points the customer has. And inside of that function, I'd have an if and else statement. The if statement would be, if the customer is platinum, return 100,000 points. Otherwise, else, return 10. So in short, we're using return as a jump expression to jump out of the currently scoped function and return the value of 10 or 100,000. This is something we're all used to seeing. Another very common use case would be checking for a null value. If a parameter that is passed into a function is null, then we return out of the function so that no other further processing takes place. So very common inside of your function. If this value is null, return, we just kind of jump right out of it and don't continue processing. Now, to wrap this up, let's see exactly what the Kotlin docs say. They say, return, by default, returns from the nearest enclosing function or anonymous function. Kind of makes sense. It returns from the function. Case closed. So we can safely assume that we know what return does. Now let's talk about the other 2, break and continue. Let's use a loop for our examples here. If you have a loop and you want to break out of it when a condition is met, you'd use the break expression to jump out of the loop. For example, let's say you were looping over 100 integers and you wanted to only show the first 25 for whatever reason. You could check the loop value, and if it's greater than 25, you would issue the break statement, which would jump you out of the loop and continue running any code that was below the loop. Okay, makes sense. Now on the flip side of the coin, if you wanted to skip a particular iteration based upon a condition, you could use the continue keyword. So for example, if we were looping over a different set of 100 integers, you could decide to only perform some operation on them if they were odd. You could determine this by using the modulo operator. If the value was even, you'd issue the continue expression, which would skip the value and then allow the loop to continue to the next iteration. Otherwise, you would print it to screen. Now, of course, you probably wouldn't use this in a real app, as you'd probably use something like filter or something of that sort, but this is just for example's sake. So if it was even, we'd skip it. If it was odd, we would print it to screen. Okay, so now we've talked about return, break, and continue. So what's up with these labels? Well, they allow us to specify where to jump to when we're using return, break, or continue expressions. That's pretty cool. But you still might be confused, and I completely understand. Hang in there. This label stuff's cool. Just let me explain. In Kotlin, any expression may be marked with a label. Labels have the form of an identifier followed by an @ sign, the same one that's in your email address. So for example, I could create a label that's called Donn @. That would be DONN, then the @ sign. So just 5 characters, DONN @. To use this label, I'd put this label at the beginning of an expression. Now let's use a nested loop as an example. The first outer loop counts up from 1 to 100, and then inside of it we have a nested loop that counts up from 100 to 200. The outer loop uses I as the counter variable, and the inner loop uses J as the counter variable. So this is all kind of something simple. We have 2 loops, one's nested inside the other. Before the first loop, I'm going to apply the label of Donn @ to label the outer loop. So what this would look like is I would have my 2 for loops nested, and right before the word for, I'd have Donn @ and have a space there. So I'm basically applying a label to the beginning here. Now inside the inner loop, I'm going to put the following condition. If the inner loop value is greater than 150, remember the inner loop goes from 100 to 200, and the outer loop goes from 1 to 100, Then I want to issue the break at dawn expression. So basically I'm telling it to break out of the loop. Now this is very similar to what you've been doing previously with break. If the value is less than 150, I'll print the value of I and j together to some output. However, if it's over 150, I want it to break out. Now, just as a side note, we're talking about a lot of code here. All this code is inside the show notes, so feel free to swipe over or take a look at the show notes on the site, and you can run it in your IDE when you get a chance to play with it. When that break at dawn expression is hit inside of the inner loop and outer loop will be broken out of. Now, traditionally, if you're using break, that would just break out of the inner loop, and we'd have to figure out something else to do on the outer loop. But since we're using a labeled break, or say break at dawn, it's going to break the inner and outer loop. Therefore, both loops are exited because of the expression label. I've told Kotlin, when this condition is met, I want you to break, but break out of the loop that's labeled with dawn at. Now, you're probably wondering, yes, that's correct. The at sign is actually flipped in the break. When we define it, we put the at sign last, so dawn at, and when we use it in front of the label. I know it sounds a little confusing over a podcast, but just take a look at the show notes and you'll get what I mean. So break allows us to break completely out of it. But what about continue? If we use that same exact example of inner and outer loops, but replace the break at dawn with continue at dawn, and I run it, I'll see that when the condition is met, which is when j is greater than 150, the inner loop will issue the continue at dawn expression, and that will then return the execution to the labeled loop, in this case, the outer loop. The next loop of the iteration will occur, and then the inner loop will execute again until that condition is met again. I know you're probably totally scratching your head right now, but trust me on this. Go run the code in the show notes in your IDE. For example, here's what I'd like you to do. Go to any file that you have, any Kotlin file, go to the top part of it, top level, where there's no definitions before any classes or anything like that are set up, so top level. And this could be inside of Android Studio or IntelliJ. And then what I want you to do is create a main function. So fun main, open close parentheses, open close brackets. Android Studio and IntelliJ will give you a play button right next to that where you can play around with the code right there inside the IDE. So it's a pretty cool little feature. Do that and you'll see exactly how these things work. Just copy and paste that code in and you can play with these different labels. Now the Kotlin docs also put it rather nicely and explains it much more succinctly than I did above. And here's what the Kotlin docs say about break and continue with labels. A break qualified with a label jumps to the execution point right after the loop marked with that label. A continue proceeds to the next iteration of that loop. So if you have a loop with a label and you break out of it, execution will occur after the loop that is marked with a label. It'll just keep running after that. If you have that same loop, but you continue with it, it will continue to the next iteration of that loop that is marked with the label. So you can get all crazy with nesting, etc., and use labels to help drive direction. Now just be aware, you can write yourself some real nasty spaghetti code if you're not careful. Okay, one last thing with working with labels and return statements. I'm going to read from the Kotlin docs as I really like the way they explain it with return and labels. With function literals, local function, and object expression, functions can be nested in Kotlin. Qualified returns allow us to return from our outer function. The most important use case is returning from a Lambda function. Now, I know this is still confusing, but let's break it down. What this means is if I have a function called example1, and inside of it, we loop over a list of integers with a for each loop, and I issue a return call in that loop, the entire example1 function will be exited because we called return. This is something that we've always grown used to when we use return in a situation like this. The function returns, game over. If I had code that I wanted to run after that loop, it would have not been run because the return statement returned out of the function. But what if I wanted to run some code after returning from that loop while still in that function? Well, with labels, we can do that. We can use a label and tell it, hey Kotlin, when this condition is met, I'm going to call return at some label. So we're telling return with some label name. And I want you to just jump out of that labeled expression and continue executing code after that labeled expression. Now, let's call that new label that we're talking as some label, let's call it bin, like bin. I'm going to put this right after my for each declaration of my function. So if I had a function and inside that function, I had a list of integers, it would read something like this. List of 1, 2, 3, 4, 5, 6, 7, 8, 9 with commas between them, dot for each, and then I have a space, and then I put my label name there. So bin at another space, and I'm open curly, close curly. So I'm basically labeling that for each loop. Now in my loop, I'll check for some value, do whatever code I need to do, some logic. And let's say it's anything greater than 7, I want to return out of that loop. So I do that by issuing a return at bin. Now execution will return to the point after the labeled expression. So if I had a print statement in there, which would be after the loop, it would now get run. Previously, without the label, that print statement would have been completely skipped. Again, there is some sample code. Please check that out. It goes through each one of these. Now, it's important to note that labels can be anything you like. If you want to call it Bob or Jane or Foo or whatever, you can do that. Now, we're about ready to wrap up, but before we go, there is one other cool trick which you can use with labels. You can use implicit labels. Implicit labels are names of functions and so forth. Using the name return at bin from above, I could remove that bin label after the for each that we had set up, and I could use the implicit return at for each label instead of having to name it myself. So now let's say you create your own, let's go a step further and say you create your own function, and this function is called make coffee, like fun, make coffee. And you have a bunch of code inside of there. It's doing a bunch of stuff, some loops and so forth, even nested loops. You could use return at make coffee somewhere down in a nested loop as an implicit label because that is the name of the function. So you have the flexibility to create your own, name it how you wish, or you can use the implicit ones. The big question is, so when should you use one or the other? Well, that depends on your situation. So you'll have to play around with it to see what makes the most sense for you and your project. Now, furthermore, you can also return out of anonymous functions, and you can also label Lambda functions as well. And so you can do more things and so forth. See the Kotlin documentation link in the show notes for more information on that. Now, lastly, you can return values with labels too. If your function returns an integer and it's labeled foo, you could return a value by calling return at foo, put a space, and then the integer value of 1. And this means return the value of 1 at the label named foo. To recap, you can use return, break, and continue with labels to provide jump expressions within your code. This can help clean up some boilerplate, but you also must be very careful to not abuse it, as you can create some real nasty spaghetti code. I hope that helps. We'll catch you in the next episode.
And before we wind the show down, I also want to thank Nevercode for sponsoring the show. Specifically, their brand new cloud-based CI/CD tool called CodeMagic. They partnered with Google and released the very first CI/CD tool exclusively for building Flutter apps. Build, test, and publish your Flutter apps in record time with CodeMagic. Check them out at codemagic.io while the service is still available to everyone for free. My thanks to Nevercode again for sponsoring the show. I want to thank Sentry for sponsoring today's show. Their tagline is, "Your code is broken, let's fix it together." They're a super cool crash reporting service that gives you all the helpful details that you need when detecting and fixing errors in your application. Don't wait for your users to report your errors and crashes. Use Sentry to catch them earlier. Check them out at sentry.io/for/Android. Once again, because Sentry is a common word, I want to make sure you get it right. Sentry.io. My thanks to Sentry for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.